perfectly and handsome love interests, or really conscientious housemates who organize everybody's chores and they clean the house quietly during the night while the rest of you are sleeping. Friendly JavaScript is all the stuff that makes your site work the way that you want it to, makes your page look nice, or it allows you to build games inside your app or see how popular your latest post is, or let you chat with other people. But there's also evil JavaScript, and there are certainly evil vampires. And in this case, when you find one of these things inside without warning, they can drain your blood, your money, your user base, your processing power, sometimes your entire life. The life and death part's mostly about vampires, although I do have another talk about code that has killed people. Maybe we can get into that another time. Needless to say, most of us want to ensure that we're only letting in the good vampires and we're keeping the evil ones away. And this handy infographic here will help to illustrate my point. Feel free to take a photo or a screenshot or print a copy and put it on your wall if you want to. Most JavaScript will end up being served from your app in one of three ways. It'll be embedded in the HTML or called from another file you're also serving, or called from another file that someone else is serving. In the security advocacy world, we spend a lot of time educating folks about the pitfalls of third-party JavaScript libraries that you might be bundling up and serving for yourselves, and about how to sanitize input to prevent cross-site scripting attacks from your users. But when it comes to the issues that are thrown by calling JavaScript directly from some other domain entirely, we don't nearly pay as much attention as we should. And maybe you personally, you're all over this and you're like, yeah, Lily, I know, it's just how the internet works. But if that is the case and you think that you don't need this talk, perhaps there is someone that you work with who needs convincing. So stick with me, because I'm going to try and give you tools and information and arguments that should help make these conversations with those people a little bit easier. We see a lot of attacks in the wild that happen as a result of sneaky third-party JavaScript. The majority of the popular ones are done for one of two reasons: mining cryptocurrencies and stealing credit card details, because the bad guys really have no imaginations. Like seriously, today's browsers can access your camera and your microphone and your screen. Far worse things are possible, but nowhere there to mine cryptocurrency, and that's about it. So cryptojacking, by which I mean using third-party JavaScript libraries to mine cryptocurrencies in users' browsers. That's cryptojacking. It was fairly popular up until relatively recently, and that was because of, hello?
Yeah, I think your slides are not moving if it is. Got it, yes.
Okay. Cryptojacking?
Yes.
Can you see that?
Yes.
Okay. And you're seeing the one that's like the one with the vampire over here. It's got like 9 of 37 down here.
Yeah, yes, Lily, that's it. It's fine now.
Brilliant. Okay. Thanks for the reminder. All right. So that's cryptojacking. Cryptojacking is about stealing your computer's resources for mining cryptocurrencies, and it was fairly popular up until relatively recently. And that was thanks to services like CoinHive. Their entire product was letting you use your browser to mine Monero. It's estimated that the actual amount of real-world money that was mined by these scripts was like about $20. And in several cases, the attackers actually messed up the attack. And so they printed the JavaScript code directly onto the page instead of executing it. So that's about the level of skill that we're dealing with here from attackers. And it has become less of a problem now because CoinHive went offline a while ago. And although there are still a few competitors out there, none of them have the popularity that CoinHive did. It's still a really bad experience for the users of those apps, though, and an overall bad experience for the planet most of the time. However, the attack I've seen most often making headlines is MageCart. It was this attack that was responsible for the British Airways and the Ticketmaster data breaches of credit card numbers and login details in 2018. That was like 400,000 people. It cost British Airways £20 million in GDPR fines. It's the European privacy regulation fines. But MageCart as an attack, it's still circulating in a lot of places. It's very popular because it is a credit card skimming attack. That's where attackers modify existing shopping cart checkout code. So they process the payment as usual, while also sending off all the submitted details in a tidy little post request to the attacker's server, where they then sell on all of those details to whoever wants them. where's my slide? Next slide. Right. So the reason that these attacks are possible is because of the way that the modern web works. So back when I was first messing around making websites in about 2001, when I was about 12 years old, one of the first things that I learned was that the primary sin that a web developer can commit was to hotlink your assets. And that is hotlinking to source a picture or another resource directly from someone else's website into your code. Firstly, it was because it was like stealing from that other person. And it would cost them a lot of money to have to keep serving their picture over and over and over to your users. And secondly, because if that person figured out what you were doing, they had the power to change that picture to a different picture that said, this webmaster is a stinky butthead. And then that's what all your users would see. If you fast forward about 20 years, we have now evolved to the practice of what I like to call extreme hotlinking, otherwise known as content delivery networks or CDNs. A major point of CDNs is to host stuff so that you don't have to, and being really, really good at serving things to you fast. But it's still hotlinking. It's still asking your website to fetch stuff from somebody else's and then trust that they are what they say they're going to be. Most of the time, this tends to work out unless the CDN service themselves decides that they don't like the thing that you're doing, or because they get compromised, or because they were never trustworthy to start with. So Scott Helm, who in my opinion, he's a security researcher, and in my opinion, pretty good one, and he is based in the UK. He puts it like this: using a CDN is consensual XSS, consensual cross-site scripting, and we are trusting the CDN not to do anything untoward. We put a lot of trust into these things. So how thoroughly do most of us evaluate what we're using? There are a lot of CDNs that will work directly with you to supply the assets you provide to your users all around the world, but there are a lot of other third-party services that are often built on the backs of these CDNs that act as public JavaScript repositories, and they will serve any version of any JavaScript library or anything in anyone's GitHub repo or NPM package directly to your site as executable code, and all you have to do is source their URL in your HTML. And I'm talking about services like JS Deliver and Unpackage and Rawgit. Many of these sites are run by passionate members of the community who want to give other developers like them the tools that they need to make great stuff. But a lot of these services are run by one person or very small teams who cannot possibly keep up with every single script that people want to use their service to serve. And this presents security issues, not just in terms of file integrity, which we'll get into in a second, but with availability. Because if you're relying on one person to keep the site up and renew the domain that your website trusts to serve it with code, that is a pretty big bus factor. So let's look at Githack, which is one of those third-party CDN services. So Githack's aim is stated right at the top of that page there. raw.githack.com serves raw files directly from various source code hosting services with proper content type headers. It is true that sites like GitHub will serve JavaScript files with content type headers that are of type text plain, so that you can't directly reference somebody's raw file into your own site, because the browser won't treat that file as executable. And GitHub does this for a couple of reasons. One of them is because they're not a CDN. But also, I guess that they can't be liable for actually running whatever random code any one of them millions of users decides to push at any one moment. So if you go and reference this file straight from someone's repo, you are saving a bit of time in uploading and serving that file yourself, but you're also trusting that the functionality of the code won't substantially change, and also that the developer or the group of developers with commit access to that repo, they've all turned on MFA and they don't reuse the same password across all their accounts, and they themselves aren't intending to do anything malicious, which is, that's a lot of trust to defer. And then you are also deferring trust to the person who cached that version of the file to the CDN in the first place. And Githack has a beta feature which allows anybody to purge any of the cached versions of whatever they want. So more or less, an attacker could come along and make sure that their malicious edit to the code ended up being the one that was cached. Rawgit, which I mentioned earlier, is a third-party CDN service that Githack was based on. Anyway, Rawgit was officially sunset in 2018, precisely because people were using the service to poison the cache with cryptojacking scripts, and then the single person who was running the service just couldn't keep up with it anymore. And despite it having been in this state for, well, yeah, about several years now, I have seen Rawgit used by sites as recently as several months ago. It could vanish anytime, or it could turn into a bat and fly off into the night, if we're going to stay on theme, I guess. And apart from developer libraries, the other reason that third-party JavaScript ends up in apps is most often because of advertising and marketing. And I'm talking about Google Tag Manager and analytics tools and advertising network spaces that you can put on your site to make a bit of money. And while I'm the first person to admit that I'm not a marketer, I don't know anything about marketing, there are plenty of reasons why people use these tools that aren't just about like pretty vanity graphs. The main issue with this type of tool, and why I'm calling it out specifically, is because these kinds of things often get added in outside of the usual developer pipeline. So Google Tag Manager, I've got my dog behind me here, in case you hear weird noises or see dogs. It's dogs. Anyway, yeah, the main issue is that Google Tag Manager it's literally code injection as a service. It can mean that marketers are able to update code snippets directly into the site. And these snippets also often call on like fourth-party JavaScript, and then it's kind of a free-for-all. And this is the place where things like mage card attacks are especially effective. This is why it's really important to know how to spot your vampires. As a developer, you might think you know what code is ending up in the HTML that gets served to your users, but you may end up being surprised. I know that supply chain problems are really hard to fix. At some point, we really do have to make decisions about who to trust, or nobody would ever build anything ever because the overhead would be way too difficult to manage. But in most cases, we can control the sources of the code that will end up in front of our users. This is really low-hanging fruit. We should pick it. So in brief, here's how you spot a vampire. You look from the outside in. As a pen tester, this is the predominant way that I look at web apps. Pen testers don't often have access to the source code. We see the app the way a user will see it, and we work backwards from there. Whereas most developers will see their site from the inside out, knowing how they've built it up and all of the checks that exist along the way. I suggest it could be educational to take a closer look at your app, the way that it's presented to your users. Use a proxy, capture the outgoing requests when the page loads, and then see exactly what you are asking your users' browsers to go to when they visit your site. Is everything that's in there subject to those dependency checkers and the vuln scanners that I know you've got built into your pipelines? Or is there stuff in there that surprises you? I know that for me, I only really became aware of this problem when I stopped being a developer and I started being a pen tester. And you might have laughed before about things like Githack and Rawgit, but I'm talking about them today because I still see them get used in live production websites, even now, all the time, mixed in with other libraries that people are serving themselves even. So I wanted to do a quick demo just to show you what I mean. I'm going to use Burp Suite here, which is professional penetration testing software. But in your work, you can use almost any kind of proxy software. And I would recommend, if you want to try doing something like this, Charles Proxy is one that ThoughtWorks provides licenses for. So if you want to try that, you can write to the software support team and get a license for that one. But I'm going to use Burp for this one. So just bear with me here. And I will share my screen. Share my desktop. Okay, can you see Burp Suite there? Just interceptors off, that kind of thing.
Yes.
Yep, okay, cool. So I'm going to open a browser just to show you what I mean. And what I'm going to do here is I'm just going to go to the BBC website. And we'll have a look at what gets loaded at bbc.com, bbc.co.uk actually. That's the BBC homepage. Okay, we'll get rid of that. So it's loading the page here. It's pulling up all the news and all of the other stuff that's going on. If we have a look at the proxy here, these are all of the things that it's pulling in as it's going. You'll notice not a lot of these come from bbc.co.uk itself. Some of them, like adserver.org, a lot of it's to do with ads, really. It's doing lots of stuff. It's getting some tracking pixels there. See that pixel? All kinds of really interesting things. And you can see this thing flashing here. It's pulling all different kinds of, here's a nice list of all of the domains that it goes and hits when you load bbc.co.uk, for example. Most of these are ad related. And most of them are like random different domains. There's a lot of Google stuff in there. But that's all of the stuff that goes behind making up this homepage that you are asking, if you're a BBC website developer, this is what you are asking your users' browsers to go and fetch just to load this one page. There's a lot going on here, but the majority of what's loading, a lot of them aren't even assets. They are analytics and advertising and all that kind of stat. And as you can see, most of them don't come from bbc.co.uk. Some of them do, a lot of them don't. And I'm going to stop that and get back to my presentation, because doing that made my shiny laptop fans start spinning, and I really don't want this presentation to stop right in the middle. Anyway, let me go back to my presentation. Share the screen. Cool. Okay. Folks now seeing this audience window thing again?
Yes.
Yep. Great. Thank you. Awesome. So how to look here. We've seen, when you've seen what you're serving, when you've done something like that and you've had a check to see where everything's coming from and hopefully gone through and seen if you recognize it, you face the unenviable task of working out what to do about it next. Don't worry, I am about to help you with that. So the first part of this is the technical solutions, of which I am pleased to inform you there are many. I only have probably about half an hour left, which is really not enough time to explain any one of these things in great depth, but I want to touch on some of them so that you can refer back to this later and dig into them if you need any of them. This slide is the one that if you feel like it, you can screenshot and go and research this stuff later if you want to dig into any of these terms. There are a lot of mechanisms you can put in place at the web app and at the browser level that will help ensure that you're only loading the JavaScript that you intend to load. I would recommend going through and reading about all of these if you don't recognize any of them, but prioritize learning about sub-resource integrity and the content security policy most of all, because they are the ones that are probably most adept at saving you. And I'm just going to give you a quick rundown of these two things. So content security policies. They're content security policies, CSPs, they're an excellent thing to include in your site headers if they're available. And you can also put them in a meta tag in the page content as well, if that makes more sense for your app. CSPs are supported by all the modern browsers, and they allow you to flexibly define a wide range of sources for scripts and other behavior that can be executed on your site. For example, if you see the default source self policy right here at the top, that one, that allows for any kind of action to be taken on the site, but only from that same origin, the same domain that your site is hosted at. So if the script is coming from there, it can do anything. And if it comes from anywhere else, none of that will get executed. And because CSPs are highly configurable, there are a lot of subtleties to understand about permission inheritance and stuff like that when you really get into it. But you can read more and you can get other examples that content-security-policy.com, which is there, or Google CSP Evaluator, which you can use to highlight any holes in your configuration. And that's that looks like this. This is the CSP Evaluator. Here is an example of that. This is just their basic sample unsafe policy to show you a bit about how they highlight that. So this is what a content security policy can look like. They can get quite long. You can define a lot of stuff here. But this will highlight down here for you some of these things like issues with the script source, where you can whitelist things that can be bypassed. Style source, that looks okay. Default source, less okay. And if you do the dropdown, you can get more information about it. But in this case, the default source contains things like wildcard there, which would allow you to load anything from anywhere and basically makes that entire thing useless because you're saying everything here is a free-for-all. It contains localhost, which in this case would mean that anything that was running on localhost relative to the user, meaning the person loading website, would be able to run in the context of that site, which would not be good. And there's other stuff down here where it can report on things like what's missing as well, which is really handy as like, to think about where you might be missing things, more or less. Anyhow, you can use the Content Security Policy Evaluator, which is when that, yeah, there you go, CSP Evaluator .withgoogle.com to have a look at that if you want to for your stuff. Okay, so that's it for content security policy. The other thing that's really important, and you should familiarize yourselves with this mechanism, is sub-resource integrity. So in brief, sub-resource integrity is a mechanism for checking the hashes of the files that you're loading to ensure that they are precisely the things that you intended to load, and then blocking them if they're not. And you can do this right in a script tag in the HTML or a link tag. The script tag is the one that I'm using in the example here. So this one would tell a browser that before executing this example framework JavaScript file here, before doing that, the browser has to compare the script to the expected hash, which is in the integrity attribute, which I've highlighted here for you, and verify that it matches. And if the hash doesn't match, the script doesn't load. And the cross-origin attribute is there to allow you to load from sources that don't require authentication. It's something that you can learn a lot more about by reading up about cross-origin resource sharing, or CORS, which I mentioned in my original slide. Anyway, these hashes, I mean, you can calculate hashes a number of ways locally and in your pipelines and so on. But you can also play with hash calculations at srihash.org, which I've put for you down here, just to have a look at how this works. But that is how you would implement sub-resource integrity. This is what it would look like in a site. Pretty much just doesn't match the hash, it doesn't load. So here's that list of tech solutions again. There's a lot in here that you can help you out. However, like all technical solutions, they don't work if you don't have buy-in from people, which leads me to the real solution here, which, like so many other things in tech, is people-based. So to stop the vampires from getting in, you're going to need to talk to people and come up with a systemic vampire management plan. This is the place to make your case for doing JavaScript right. You can talk about the worst case. You can use the notable attacks I highlighted earlier if you like, or just Google for MageCut, M-A-G-E-C-A-R-T, because there are more MageCut attacks happening all the time. Talk about the user experience that you're presenting to your customers if you can't guarantee that the JavaScript that you're calling on is the thing you intended it to be. And most importantly, work with your like-minded teammates to come up with a strategic approach for tackling this, because in a lot of established businesses, it can be really, 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 really hard to make a case to anyone whose sole concern is not security, which is a lot of people. And in our ideal, amazing, golden utopia state, we would select each one of our vampire guests with incredible care, which is to say that we would only include the specific JavaScript that we needed. We would host it ourselves. We would have a lovely maintained register of all the stuff we were using, all the dependencies. We would automate our updates and our patches. Nothing at all would happen outside of the normal developer flow, and we would all live happily ever after. But we know that life isn't like that. It's not always going to happen that easily. So once you have done your looking from the outside in that we were talking about earlier, and you've tracked down what kinds of JavaScript your web app is actually serving to people, and you can start looking at your short, medium, and long-term plans for getting to that ideal state. This is going to vary depending on the challenges that you face at your specific workplace. So please adjust these to suit you. You might find that you never get to that ideal state, and that's okay. You're just one person. We can't win all the fights. Every client is different, but see what's within your ability to control. So with that caveat, here is my suggestion. In the short term, find out exactly where all of that outside-in JavaScript is coming from. Do you recognize it all? Is it all covered off in your usual deployment process, or is there stuff that's being added in that you weren't aware of? If so, go and find out who added it, where they fit into the thing, and what their actual use cases are. Empathizing with these folks is going to be really important too, because they are just doing the best at their jobs, and they might not have realized what kind of risks they're introducing. So do your best to understand what they're trying to achieve, and if there is a more secure way that you can help them achieve it. I mean, does it mean that developers and marketers pair on Google Tag Manager work? Maybe. Does it mean we need to start looking at whether we can host more of our own stuff? Perhaps. This is the period of time where you, with all of your consultant power, should try and start getting folks on side. Medium term, trial some of these process changes and then adjust them where it's needed. This is also a good time to start working on how to roll out some of these basic technical controls I mentioned earlier. Although I know that content security policy implementations in particular, they can be a real pain. So that's why I say start working on and not roll it out right now. By now, you should also have a clear list of what you're serving to people, and you can at least be monitoring that for any changes and incorporating as much of it as you can into your usual pipeline so you have all of those checks that you would normally have for everything else. This is also the point to start assessing the CDNs that you're using and asking yourself questions about their security practices, their reliability, and so on. Are there any that you can pare back? Or can you at least use one source if you're using multiple sources? See what works for you. In the long term, you want to work toward getting everything using sub-resource integrity at a minimum and content security policies if you can manage that. Hosting this stuff yourself is ideal from the perspective of being able to strictly control the domains from which you will accept JavaScript, which will, you can tightly maintain a list of third-party sources that way, and then evaluate new ones as you go. And this will help to ensure that things can't just get pushed out willy-nilly by anybody. You can't just accept a new domain. By this stage, you should also hopefully have as much as possible under that one umbrella. Developers and marketers working together to ensure that the scripts that are being deployed are all serving useful purposes and coming from the suppliers that can make reputable guarantees about their own security. And once you've done all of that, you will be totally 1000% unhackable, certified guaranteed, safe from all vampires forever. The end. Okay, no, you won't. Sorry. There are still a lot of other things that you need to keep an eye out for, and security issues never end. The security issues that are involved with using third-party JavaScript, they are one small facet of the larger issues that can occur with making computers talk to other computers. And for better or worse, we are all in this never-ending game of cat and mouse together. All we can do is our best and keep on top of the risks that we're exposing both ourselves and our users to in the course of our work. I have compiled a list of resources on my website. If you want to refer to any of this or dig into the sources I looked at while researching this talk, you can go here. I've put that up there, and I will continue to update this as I give this talk again and refresh the content. And as more stuff happens, because more stuff happens all the time. And that's it, really. I just wanted to leave you with one of my favorite vampire tweets that has made me smile many times. Anyway, thank you very much for listening. And yeah, are there any questions? So quiet. Have I satisfied every answer that you have about third-party JavaScript?
I had one question related to the sub-resource integrity.
Yeah.
So how do you see that is effective in terms of transitive dependencies as well as inline scripts?
Mostly for the actual scripts that you are hosting, or that you are referring to yourself, like if it's a static source.
Yeah, so basically we kind of take a static source, and then since it has to be within the relative, it has to be hosted by us, right? So you host it. But in case there are dependencies from the script to something else.
Yeah, no, it's mostly just about that script itself. And also you don't have to host that script yourself. It could be anywhere. You don't have to have you don't have to host the file to be able to have a hash for it and verify the contents of what is there.
Okay.
But it is just verifying the contents of that one specific script to make sure that it is what you say it is. And hopefully you will be checking that kind of script, especially if you are calling and creating a hash for it. Hopefully then you will say, right, well, this is a valid script that I wanted to use, and you will know what those transitive dependencies are. You will know what else is going on underneath the hood there. The whole idea here is that in that case, nobody can sneak in a new one, or the hash of the file would change and then it wouldn't load.
Absolutely right. But the other point is, with the hash, there is a safe assumption we make the original script is the right one and it is secure. And the hash is due to the integrity. But if the original script itself has something and we compute a hash along with that, we can't identify that, right? That problem still exists.
That's right. Yeah. So what this is doing is more or less making sure that you are loading these scripts you intend to load. It is also built on the assumption that the scripts you intend to load contain things that you want. And if they don't, that's where you would probably want to make sure that you are going through what you're asking to load in that case. If it's a known library, that generally shouldn't be a problem. But it is always worth knowing what you are actually loading at the end of the day. Even reputable libraries and things like that, you should be able to rely on. But if it's a little bit weird or out there, or if it's a custom thing, that's where you would definitely try to know as much as you could about what was there. Sub-resource integrity is also just making sure that if somebody else sneaks in and tries to load a URL to something else, that won't work. So it can't just be arbitrary. But it is making the assumption that the developers know what they're doing and they are calling on the right stuff at the file at the other end.
Sure. Thank you. And for the hash also, it should be more of an agreement from the third party who is giving the script that this hash is the final one and does not have any problem, right? It's a secure file. Yeah.
No, you can hash any file you want. It's really up to you as the developer to verify that the file that you are specifying is a thing that contains things you want to load. What it's protecting against there is mostly that somebody else can't sneak in and put some other random file in and try and call that file and ask for it to load instead. But you are then verifying that nobody has changed the contents of that hash between the time that you publish the hash yourself and the time that the browser loads it. So the browser is doing that verification.
Sure. Thank you.
No worries. Anyone else? I can see faces of people in here who have good questions.
Are there any tools or scanners which would scan these vampire scripts?
There are definitely things that you can do to check when you're building stuff, what is there. We should have a lot of dependency checkers and things like that. Sneak is one of them. I think you pronounce it Sneak, SNYK, which will check dependencies of things particularly when you're talking about NPM packages and stuff like that. But in terms of checking what's actually loading for your users, that's where looking at it through a proxy, when you come looking at prod through a proxy and seeing what it actually looks like at the other end, once everything gets injected everywhere and you've got your final product, is sometimes a really instructive thing to do because it can surprise you. In terms of the scanning, I'm not sure if there's any scanners that exist that do this. There might be, but it's worth just having a look every now and then to check in, honestly, just to see whether it looks like what you expected. Because as you saw from the demo earlier, or hopefully my screen sharing worked, there's a lot of stuff that can go into, so many domains that get called on for all kinds of different stuff. And that's like trust that you are deferring to every single one of those domains, that everyone who operates every single one of them is going to have done the right security things that you would expect them to do, which is wild because no one does.
Okay, thank you.
No worries. I'm sorry, that wasn't a very complete answer. The TLDR is, I don't know. Anyone else? Did anyone learn anything that they didn't know before? The thumbs up. What did you learn that you didn't know before? Be keen to hear.
I didn't know the link for the Csp Evaluator tool.
Awesome. It's a really handy one. I use it a lot.
Yeah, it's great. Thanks.
What else?
One question on to the CSP, sorry.
Yeah,
related to the
go for
transitive,
it.
because I mixed the transitive dependency to the other one. So CSPs are loading specific things that we want to load on the site. And then we are kind of giving the list of domains we kind of trust and load. What if the script that is having a dependency, maybe a transitive dependency to some other script, because as you said, CSP is a hard thing to implement because it has a larger regression path. Have you seen some kind of scenario? Maybe the inline dependencies are okay, we can kind of handle it out, but on the transitive dependencies, which happens on the runtime almost. So
Yeah. It will block things from loading that don't come from those domains. So if if your script is trying to go out and fetch other things, if those things aren't allow listed, it won't work.
so we have to go and find all the domains it has the dependency, and then kind of build that CSP, or the CSP suggest the tools you suggested will be able to find these as well. Transitive
Oh no, you have to build it yourself. That's also part of it.
Okay.
Is making sure that you're very clear about what you've got and that you're defining it as clearly as possible.
Okay, thank you.
Yeah.
This is a question regarding cross-site scripting in general. So regarding persistent cross-site scripting, let's assume the script has entered the system and it has entered the database. Is there any tools to detect those kind of scripts which doesn't belong there and eradicate them at the database level?
At the AWS level?
Sorry, the database.
Oh, the database level. I misheard you. Sorry. Oh, that's a good question. There probably are. This is separate from the problem of third-party scripts, of course, because when you have what you're describing as like stored cross-site scripting, and at that point, a content security policy won't help you most of the time. It can in certain ways, but mostly if it's stored, then it's stored on your domain, and we will want to trust the things that come from our own domain. So there are definitely tools that you could use. I say there are definitely tools you could use.
Maybe we can think about some anti-SAMI. We can just encode that and then encode the response back so that it don't reflect on the browser because the data is already stored. Or if you want to find that activity on the data, is there a way SQL queries provide you to find such an encoded patterns are available via query? Those are the two things I'm able to think about.
Sure.
Yeah. That's the most common way to deal with cross-site scripting, is to make sure that you are, making sure that you encode things that users are putting in and dropping stuff. But that doesn't help you detect stuff when it's already been stored accidentally. In that case, running through what you've got with proper, there's a good script scanner. Possibly. I haven't used that one.
And one more interesting thing about the Excel.
That's cool. I have to look into that.
We already have headers like to prevent excesses, right? And we also have CSPs these days. I see these, some of the headers are deprecated, but how much of this is communicated in terms of the overall community, the usage of these XSS headers with CSP, so that we don't do a lot of over engineering and try to keep things to the sensibility first, because this is something as a practice that happens every now and then, but I'm not too sure what is the right way.
Most of the headers have been deprecated in favor of using a CSP instead. Some people keep them there because they want to support things like Internet Explorer, which don't support content security policy. But they have also got lots of other legacy problems when they do that, because, you know, supporting older browsers can be a problem. Yeah, Dependabot for scanning a source code is really good in GitHub. That's right. Sorry, what was the original question?
The question was more about how effectively we can say we can just concentrate on CSP alone. We don't need to worry about these XSS headers, because few sites like Mozilla Observatory still believe on these headers. Are this more from a older browser support? There is not a clear communication or clear direction to do.
I mean, throwing in extra headers, it generally won't hurt. If you have like an XSS protection header, for example, and a CSP header, you can have both at the same time. That's okay. And that will ensure good backwards compatibility for browsers that don't happen to support these things. As we go further into the future, it will be more likely that browsers will be supporting CSP. But until that time, there's no harm in putting any of these other headers in there as well. You know, that will help. CSP, particularly when it was new, there was a lot of this like cross compatibility stuff. And depending on what your customers look like for any given client, it may still be worth throwing in those old headers, because, you know, not everyone can afford to upgrade their computers all the time. Some people are still using Internet Explorer. So it helps protect them as much as anything else. But I think that things like Mozilla Observatory will update their rules the further into the future that we get.
Sure, because somewhere I kind of studied that even the XSS headers are also causing the XSS, are helping the XSS in some way. I'm not too sure about that. Is that true? I don't know. That's the reason people are favoring CSP as well, because XSS is more about telling the browser to do the audit. All right.
Yeah. It's a less fine-grained way of doing it than CSP. CSP is like the Swiss Army knife of this kind of thing. But there's nothing that says you can't do both at the same time. You can have both headers just to cover your bases.
Sure. Thank you so much.
It's okay. Cool. We have like 10 minutes left. I can see folks dropping off the call, but I'm happy to stick around for the last 10 minutes if anybody wants to ask anything else.